Okay, now that we've got our thermocouple wired up for our transient measurements, we're going to look at our code really briefly. DAC assist, the actual input signal from the thermocouple, was set up the same way that it was before. We're going to go through and we're going to work this again using our cold junction compensation, putting in a constant value. In this case though, we do want to have a temperature output to a chart, and then unlike the previous case where we had a write to file button, we're going to continuously write data to the file so that we see the transient events and their total behavior. So if we look at our output, we've got our chart. So going forward, we've got our expected scale that we're going to go between ice and room temperature. So we've set that to maintain the Y scale at -5 to 30 degrees C. And then an important feature that we have is that we're going to change our output mode or update mode to a strip chart. So what that's going to do is it's going to continuously append all of the data onto the chart so that we see the entire event. We can see where the temperature began to change, and we can see where the temperature rises or falling depending on which direction we go from. And again, the key there is that we're going to capture the entire data point because our write to measurement file is constantly operating as opposed to our steady measurement file where we actually hit a write to file button.
All right, we're now going to go ahead and record some transient data so that we're able to go ahead and calculate the time constants. So the first thing that we're going to show you is taking the thermocouple from the iced water into some water at room temperature.
All right, we'll go ahead and start the code. Code's running, we've got temperature at 0. We can now see the steep increase in temperature as we go from freezing up to room temperature water. We see the curvature as we've expected for a first order response. So we're still very slowly approximating a final temperature.
Starting to stabilize now.
Yep, temperature's starting to flatten out.
Okay, and now we're going to go back to the ice temperature water.
And we should see the opposite behavior. So again, steep drop off in temperature. Now we're going back to approaching a temperature that is on the order of 0 degrees. And we can see too, right, even though we went between the same two temperature sources, we got a much different time-based response between going from the ice to room temperature water as we did from room temperature water back to ice. We've almost already stabilized now going back to the ice temperature. So we'll go ahead and hit stop and record this data to our file.
Okay, so now we're going to do exactly the same thing, but this time we're going to use our room temperature as air, right, instead of the water at room temperature. And this should demonstrate to you the difference in time constants between going from air to liquid and liquid to air, right? So I have my thermocouple sat here in room temperature, in air, and then when we're ready to go ahead and record the data, I'm going to dunk it in the ice water.
Okay, I'm going to start the code. We're now running, so go ahead and insert it. Again, we see a sharp decrease in temperature as we approach from air temperature down to ice temperature. We're going to give it a few more seconds to stabilize.
All right.
Okay.
So now we're going to pull it out of the ice bath and just leave it in the room temperature air.
So if we compare the sharp decrease that we had from air into ice, we can see that the temperature change from ice back into air is a much more gradual change. So what we're going to do is we're going to run this for enough time to have sufficient data to extrapolate the behavior, predict the time constant. But with this, completing the transient behavior measurements, this will end the temperature lab.